Today we're continuing on in our Eureka math, that's what EM stands for, and it's lesson 1.2, so that means it's module 1, lesson 2. And your learning goal today says, I can use what I know about place value. We've been talking a lot about place value these past couple days, so you know a lot about place value. And we're going to use it to help us multiply and divide by factors of 10. Today's math learning goal says I can use what I know about place value to help me multiply and divide by factors of 10. In order to accomplish that, we need to first understand what is a factor of 10. Well, a factor of 10 is any number that you get by multiplying tens. So an example of a factor of 10 is 10. What's another example of a factor of 10? Kazu? 20 is not a factor of 10 because you have to multiply 10 times 2. In order to get factors of 10, you can only multiply 10. 100, there you go. What's another factor of 10, Lydia? 1,000, you got it. What's another factor of 10, Luke? 1 million. What's another factor of 10, Niv?
1 billion.
1 billion. What are you guys noticing about these factors of 10? Are they all on the place value chart? They're all the different places on the place value chart, aren't they? So today we're going to be multiplying and dividing by numbers like 10 or 100 or 1,000 or 10,000 or 100,000 or 1 million. What would the next one be? No. What's after 1 million? 10 million. Then what? 100 million. And then 1 billion, etc. Okay, very good. Now, in this problem, 367 times 10, am I multiplying it by a factor of 10? Yes or no? Yes. What is the factor of 10 that I'm multiplying by? 10. That is a factor of 10. It literally is 10. Okay, so I can put 367 in my place value chart. If I'm multiplying by 10, do I need to shift it to the left or to the right? Do I need to shift those digits to the left or to the right when I multiply by 10? Left. How many columns or how many times do I have to shift the digits? 1. Because how many times do I have to multiply 10 to get 10? Once. So I just have to shift it once. So what is 367 times 10? It's 3,670. Very good. Now, same thing in my next problem. Go ahead and copy it down. 367 divided by 10. This time I'm dividing. When I divide, which way do I need to shift the digits? To the right. How many times? Well, let's take a look. What factor of 10 am I dividing by? I'm dividing by 10. How many times do I have to multiply 10 to get 10? 1. I only need 1 10 to get there, right? So I only have to shift it 1 time to the right. So 367 divided by 10 is equal to 36 and 7. What? My 7 is now in the tenths column. Very nice. Okay, so now we have 215 and 6 tenths. Okay, let's start with the first one. We're going to multiply it by 100. Okay, so go ahead and put it in your place value chart. The 2 is in the hundreds column. There's 215 and 6 tenths. This time we're multiplying, so that means we need to shift the digits to the, which way? Left. And this time, what are we multiplying it by? 100. How do I get 100? I have to do 10 times what? 10 times 2 is 100?
No, 10.
10 times 10. So because I had to use 2 tens to get 100, how many times do I have to shift those digits?
2.
2. So 1 is not going to be enough. It's going to be 2. So my answer is going to be 21,560. Do you see how we have to shift it 2 times because there's 2 factors of 10? Make sense?
Mm-hmm.
Okay, let's try the same thing when we divide. Again, we start with 215 and 6 tenths, and this time we're dividing. So which way do we need to shift the digits? To the right or to the left? to the right. And how do I get 100? Well, 100 is, once again, 10 times 10. So how many factors of 10 are there right there? If I have 10 times 10, how many times does the 10 appear? 10 times 10. How many factors of 10 are there? 2. So how many times do I have to shift the digits? 2. 1, 2. So that one would go there. This one would go here. This one would go here. And then this one would go here. So my answer, 215 and 6/10 divided by 10 is 2 and 156. What place value is that? Thousands. So it's 2 and 156 thousandths. So this time we're starting with 482 thousandths. By the way, do I technically need to write this 0? Does this 0 have any value? If I didn't have it and it was just 0.482, is that still the same thing? Yeah, but the decimal point sometimes is really small and it's hard to see. So if you put the 0 in front of it, it tells the person who's reading it, oh, there's probably a decimal point there. So it's best practice to always write the 0 in the ones place. Got it? Okay, we have 482 thousandths, and what are we doing this time? Are we multiplying or dividing? Okay, so the multiplying tells us right away that we need to shift to the left. And we're multiplying by what this time? 1,000. Okay, how do I make 1,000 just using tens? 1,000 is the same thing as 10 times what? 10 times 100, or remember, I only want to use tens. So it's 10 times 10 times 10. How many times do I have 10 there? 1, 2, 3. So how many factors of 10 are there? 3. So how do I have to shift those? I have to shift it to the left. How many times? How many times?
3.
So 1, 2, 3. So the 4 would go here. The 8 would go here. And the 2 would go here. So what's 482 thousandths times 1,000? 482. Lydia says she's noticing a pattern. When there's 3 zeros, that means that there were 3 factors of 10. And we have to shift it 3 times. Interesting. Does that hold when we had 100? How many zeros are in 100?
2.
And how many factors of 10 were there?
2.
When we had 10, how many zeros are there?
1.
And how many factors of 10 are there? Interesting pattern noticing. Okay, let's try this one. We have 482. Be careful, is it 482 thousandths or just regular 482? Okay, and this time are we multiplying or dividing? Which means we're shifting to the? Okay, let's use Lydia's pattern. How many zeros do you see? That means how many factors of 10 are there?
3.
That means how many times do we have to shift it? 3. Okay, so 1, 2, 3. The 4 would go here. Wait, is that?
Yeah, the 4 would go there.
1, 2, yeah, 4 would go here. Okay, so the answer was 482 divided by 1,000? 482 thousandths. Very good.